A subpanel with the main breaker cannot be fed with conductors rated for less amperage than the main breaker. For example, if you have a 200 amp main breaker in the subpanel, the conductors feeding that subpanel must be rated for at least 200 amps. This is a fundamental principle of electrical safety and is mandated by the National Electrical Code and local electrical codes. The reason for this requirement is to ensure that the conductors are adequately sized to handle the potential current flow through the breaker. If the conductors are too small, they can overheat, leading to insulation damage, fire hazards, and potential equipment failure. The main breaker is designed to protect the entire subpanel and its downstream circuits from overcurrent conditions. If the conductors feeding the subpanel are undersized, they can become the weakest link in the system and fail before the breaker trips, creating a dangerous situation. The National Electrical Code, specifically Section 310.15 and related tables, provides detailed guidance on conductor ampacity based on factors such as conductor material, insulation type, ambient temperature, and the number of current-carrying conductors in a raceway or cable. It's crucial to consult these tables and apply the appropriate rating factors to determine the correct conductor size for a given application. When selecting conductors for a subpanel feed, consider the following factors. Firstly, the ampacity of the main breaker in the subpanel. The conductors must have an ampacity equal to or greater than the breaker's rating. Secondly, the ambient temperature where the conductors will be installed. Higher ambient temperatures reduce the ampacity of conductors, so rating factors must be applied. Thirdly, the number of current-carrying conductors in a raceway or cable. When multiple conductors are bundled together, their heat dissipation is reduced, requiring rating. Fourthly, the type of insulation used on the conductors. Different insulation types have different temperature ratings, which affect their ampacity. Fifthly, the length of the conductor run. For long runs, voltage drop can become a concern, requiring larger conductors to maintain adequate voltage at the subpanel. In addition to the National Electrical Code, local electrical codes may have more stringent requirements or specific amendments that must be followed. It's always best to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. Ignoring these code requirements can have serious consequences, including fines, penalties, and potential liability in the event of an electrical incident. Furthermore, undersized conductors can compromise the performance of the electrical system, leading to voltage drops, reduced power availability, and equipment malfunctions. Always err on the side of caution and use conductors that are adequately sized for the intended application. The cost of using slightly larger conductors is minimal compared to the potential risks and costs associated with undersized conductors. When working with electrical systems, it's essential to prioritize safety and follow all applicable codes and regulations. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. They have the knowledge, experience, and tools to ensure that the electrical system is installed safely and correctly. They can also provide guidance on conductor sizing, breaker selection, and other electrical-related issues. Improperly installed electrical systems can pose a significant safety risk to yourself, your family, and your property. Don't take chances when it comes to electricity. Always follow best practices and consult with qualified professionals when necessary. Remember that the National Electrical Code is updated every 3 years, so it's important to stay current with the latest requirements. Local electrical codes may also be updated more frequently. Staying informed about these changes can help you avoid costly mistakes and ensure that your electrical system is compliant with the latest regulations. Many resources are available to help you stay up to date on electrical codes and best practices, including online training courses, industry publications, and professional organizations. Take advantage of these resources to enhance your knowledge and skills. When it comes to electrical safety, there's no substitute for education and experience. Continuously learning and improving your skills can help you avoid accidents and ensure that you're working safely and effectively. Furthermore, consider the type of load the subpanel will be serving. If the subpanel will be supplying power to heavy loads such as air conditioners, electric heaters, or electric vehicle charges, the conductors may need to be sized larger than the minimum required by code to account for the increased current demand. It's also important to consider the diversity factor of the loads. The diversity factor is the ratio of the maximum demand of a system to the sum of the individual loads. If the loads are not all likely to be operating at the same time, the diversity factor can be used to reduce the required conductor size. However, it's important to be conservative when applying diversity factors to avoid overloading the conductors. In addition to conductor sizing, it's also important to select the appropriate type of conductor for the application. Conductors are available in various materials, including copper and aluminum, and with different insulation types. Copper conductors are generally preferred for their superior conductivity and corrosion resistance, but aluminum conductors are often used for larger sizes due to their lower cost. The insulation type should be selected based on the ambient temperature and the presence of moisture or corrosive substances. When installing conductors, it's important to follow proper wiring practices to ensure a safe and reliable connection. This includes using the correct size and type of connectors, properly torquing the connections, and protecting the conductors from physical damage. Loose or improperly torqued connections can cause overheating, arcing, and potential fire hazards. It's also important to label all conductors clearly to avoid confusion during future maintenance or troubleshooting. A well-labeled electrical system is easier to understand and maintain. When working with electrical panels, it's important to follow lockout/tagout procedures to prevent accidental energization. Lockout/tagout procedures involve disconnecting the power source and applying a lock and tag to the disconnect switch to prevent it from being turned back on while work is being performed. This is a critical safety measure that can prevent serious injuries or fatalities. Before working on any electrical equipment, always verify that the power is off using a voltage tester. Never assume that the power is off simply because the disconnect switch is in the off position. A voltage tester can provide a reliable indication of whether or not the equipment is energized. It's also important to wear appropriate personal protective equipment, or PPE, when working with electrical systems. This includes safety glasses, insulated gloves, and appropriate clothing. PPE can protect you from electric shock, burns, and other potential hazards. When working with electrical systems, it's always best to be cautious and take the necessary precautions to protect yourself and others. Electricity is a powerful force that can be dangerous if not handled properly. By following proper safety procedures and using qualified professionals, you can ensure that your electrical system is installed and maintained safely and reliably. Remember that electrical codes and regulations are constantly evolving, so it's important to stay up to date on the latest requirements. Consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. They can provide valuable guidance and help you avoid costly mistakes. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It's updated every 3 years and is widely adopted by states and municipalities. The NEC covers a wide range of topics, including conductor sizing, overcurrent protection, grounding, and bonding. It's an essential resource for anyone working with electrical systems. In addition to the NEC, there are other industry standards and best practices that can help you ensure the safety and reliability of your electrical system. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. By following these standards and best practices, you can minimize the risk of electrical accidents and ensure that your electrical system operates safely and efficiently. Remember that electrical work is not a do-it-yourself project. It requires specialized knowledge, skills, and tools. If you're not qualified to perform electrical work, it's best to hire a licensed electrician. They have the training and experience to handle electrical projects safely and effectively. Trying to perform electrical work without the proper qualifications can be dangerous and may violate local codes and regulations. Always prioritize safety and consult with qualified professionals when necessary. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before performing any electrical work. They can assess your specific situation and provide tailored recommendations based on your local codes and regulations. Electricity is a powerful force that demands respect. By following proper safety procedures and consulting with qualified professionals, you can ensure that your electrical system is installed and maintained safely and reliably.